Some integrated scientists in here and maybe even some astronomers. I opened it up to let anybody that's curious. I've never been here. How many have ever been here? Nobody.
All of us right now.
Well, yeah.
There you go.
But had no idea this was back here.
Yeah.
So my name's Joe Whistler. I've been with the wastewater plant here in Lincoln City since 1981. So if you all remember back in 1981 how things were back then, you remember 1981.
Yeah. I was maybe a twinkle on the inside.
Yeah. So you might remember.
Yeah, but I've only been here 8 years.
I'm actually from the area. I was born in Newport, raised up here. I graduated from Taft High.
Nice.
The old Taft High. So did the service, didn't know what to do. My brother did water treatment and water works, and I decided, well, I'll do water. Went to college, did a couple of years, got my associate's degree in water and wastewater technology, and at that time they were building this treatment plant, the one on in the picture there, the big picture. So they hired me, and I've been here ever since. It's an interesting kind of job. I really enjoy it. Actually, I like it over water treatment. When you guys all went to the water treatment plant, a lot of chemistry, we have a problem, so we add chemical, and it's a 1-for-1 addition. Here we use biology, we use microbiology, we use bacteria to remove the waste from the waste stream. We just finished upgrades in 2008 and 2012, so it's actually a different plant than you see in the picture. We have got a new picture up. Wastewater is basically the same, though. You take raw sewage, we put it into a basin. I can show you on this picture. This is the simplistic. It comes in here, we screen it, take all the rags and garbage out, the fish, the garbage, the toys, everything out. We send it to the next unit. That unit takes all the inorganics, the heavy solids. Sand gets in the line, gravel can get in line when there's breaks. We take the gravel out, we put it into a basin, we aerate it, and we can take just the raw sewage. Just take the raw sewage and you put air to it, it will form its own microbiology, it'll form its own bacteria that will start eating itself, and it creates a biomass. We call it a mixed liquor, everybody else calls it sludge. It's the brown, I'll show you some samples in the lab. Just the sludge, we mix it, we aerate it, we try to keep the bacteria happy. After it's mixed and aerated with the raw sewage, we put it into a tank, and in the tank it settles, the solids come to the bottom. We take the solids off the bottom, we pump them back, and they meet the raw sewage that's coming in. So the raw sewage is the food, the bacteria, the bugs, they eat the food. That's just basically it. The water comes off the top of the clarifier, and it's treated further for pathogens and bacteria before we discharge it into the creek. The solids, because the solids keep eating food, they keep producing, growing, so we have to take a portion of them out. We try to balance between how much food is coming in and how much solids, or the bacteria, how much bacteria we have to meet that raw sewage. And so we'll get rid of them. If you have too many bugs, they'll starve, they'll die, they'll come off in your treatment. So we get rid of them, we put them into we call aerobic digesters. And once they enter the aerobic digesters, there's no more food, they start breaking themselves down, they start eating each other and reducing the volatility, the organics of the solids there. We'll, after they've been through the aerobic digestion process, we have sludge holding lagoons. We'll put the sludge out in the lagoons. A year after they've sat in that lagoon for a year, we test them, and if they qualify, they become what we call biosolids. Biosolids, it depends on mainly the bacteria content, the pathogen content, and the volatility, how much organics is left, and we take that and we use it for fertilizer in the valley on pasture fields. It's not used for human use. It's called a Class B biosolids. So that's wastewater treatment. So our new treatment plant, you're going to see it's different. So out in the city, how many people live in the city? And all you people who live outside the city, right? You have septic tanks, right? Guess what? It all comes here. The water goes out through your drain field. All the solids that stay in there, they end up ultimately here, and we treat those too.
So when they drain the tanks, the septic
when they
tank,
pump that tank, it actually comes here. I don't know if you just missed one of the guys.
Oh, yeah?
Actually discharging here.
Oh.
So
so do they want to come
If you
across
wanna
the
see-
counter to take
so,
a
yeah,
closer
there-
look at this?
sure, you guys
Come
can
on.
come in. Yeah.
Gather around.
This is the big office. So our new treatment plant is just a little different than the other one. We have 4 individual basins. Rather than that going to the aerator and then going to a settling basin, they will go into a basin
Makes it easier.
and batch mix. They'll go through a process each. Let me see if I can see it. So each of the 4 basins will be in a different state. When you go out there, you'll see there'll be one basin that's taking in the raw sewage. It's going to mix with the raw sewage.
So number 4 is getting the raw sewage right now.
Actually, number 4 is getting the raw sewage right now, and so it's filling up, getting the raw sewage. When it's full at a certain time, this is all designated by time. At a certain time, it'll quit. Number 1 is now decanting. The water's coming out from it, like it would that clarifier. One is being emptied, one is being filled all the time, and the other ones are in various modes of either react, which is aeration, or settling. So you have the 4 basins. So each of these basins is working individual of each other, so it's like 4 treatment plants going on at the same time. And rather than doing a separate aeration basin and clarification basin, it's all done in one basin. We have floating decanters to take the water off, and then the water goes off. The water goes. You'll see. I'll take you down and show you the filters. There's 2 sets of filters, and then we now use ultraviolet disinfection. We used to use chlorination. We'd add chlorine to kill the pathogens, and then we actually have to remove the chlorine by using sulfur dioxide. And the city chose to go to using the ultraviolet light. It actually does both. There's no residual left over. It destroys all pathogens.
Virus.
It actually disrupts their cells, and they can't reproduce anymore. So that's it, and then the flow, then the solids go over to. We have 2 digesters. If you're lucky, you'll get to see the digesters. It's the best part of the whole trip. It's the good stuff.
So you like that ultraviolet? I know it's state of the art. I mean, it's what everybody's going to. But do you like using it?
Oh, very much, yeah. The chlorine takes time, contact time. You have to have a certain amount of contact time going on. You have to then just remove that disinfection after you're all done. So it's a balance, because you don't want to put any chlorine in the creek. You don't want to put too much sulfur dioxide in the creek, because it uses oxygen. Takes the oxygen away from the life out in the creek. So ultraviolet, it's instant.